All right, let's take a look at our worksheet for Chapter 4, Section 1, talking about the development of a new, looks like the Bohr model is just around the corner. That's probably what you picture, what you imagine when you think of an atom, more or less, unless you're picturing more of the Rutherford model, which we've already talked about. It's that kind of planetary model. And it kind of has the different orbits of the electrons represented kind of as orbits like planets around a star. That's the way that Ernst Rutherford described it. But we're going to start setting the stage for the Bohr model of the atom, which is, if you've ever seen a representation of an atom with a nucleus in the middle and then concentric circles moving out from the nucleus, but those concentric circles are in the same plane. That's representing the Bohr model, most likely. And so that's what we're going to move toward. And so, let's get started. Number 1, in what way does the photoelectric effect support the particle theory of light? Well, in order for an electron to be ejected from a metal surface, okay, remember that's what's happening in the photoelectric effect. This plate of metal, this metal surface, is ejecting electrons. That's the effect. So, and it was pretty darn confusing at the time. It actually took Albert Einstein a Nobel Prize to actually explain it. So in order for an electron to be ejected from a metal surface, the electron must be struck by a single photon with at least the minimum energy needed to knock the electron loose. And this was kind of confusing at the time because at the time light was understood to be a wave. And that means that the supply of energy is more or less, it's constant. And what that means is you can basically, the idea, right, the consequence of that idea is that you'd be able to eject an electron with any frequency of light, any energy of light, so long as you allowed that energy to kind of build up in the atom, that metal atom. Because the light was actually supplying a continuous kind of almost like a charge, right? Like charging a battery, not charging like plus minus. But you're charging up that atom until the electron finally stores up enough energy to be ejected. Well, that's absolutely not what the experiment showed. The experiment, the photoelectric effect experiment, showed that unless that electron was struck by a single photon, only one, with that bare minimum threshold of energy, unless the electron was struck by that bare minimum of energy in the form of a single photon, that electron would not be knocked loose at all. Okay, and so that means that there's a minimum chunk of energy that is required to actually do work on a system, which is one of our definitions of energy. So there's this minimum amount of energy, which was later dubbed a quantum of energy.